Welcome to another video about linked lists. In this demo I'll examine how a linked list behaves when returning an element using the get method and when replacing an element using the set method. These are the two methods I'll discuss. So get returns the element at the specified position and set replaces the element at the specified position with a new element. And this is a sample code. In the main method I start by creating a linked list object and filling it immediately with 6 elements. Next I'll obtain the element at position 4 using the get method. Then I'll change the element at the same position using the set method. Executing this code will produce following outputs. Let's find out in a memory layout what happens when I execute these get and set statements. The linked list object having 6 elements is already created, and this is where I left off in the previous demo. So with local variable nrs allocated in the stack frame referring to the linked list object on the heap. So with the first we point to the first node, via the next node we navigate all along the chain of nodes, and with the previous property of every node we navigate all along the previous nodes in the opposite direction, and we have a size of 6 nodes. Now let's obtain the element at position 4, so the 5th element. First, local variable elements that will hold the result is allocated in the stack frame. Then, executing get, we arrive at the linked list class of the GDK. Let's set up the stack frame for this instance method call. So at the first position the this pointer, and at the second position the index 4. And a space is reserved for the return value. After executing an index out of bounds check, the node method is invoked in order to determine which node we want to access. It is the same node method I've discussed in early videos when I added a new node before another one. Passing the method an index, it returns the node at the position with value index. So let's invoke it. Setting up the stack frame. So this pointer and the index with value 4. Now from where do we start iterating? If index, which is 4, less than size 1 bit shift to the right, which comes down to the division by 2, so size is 6. 4 less than 3, is that the case? No. So we start from the back. So a local variable x is allocated on the stack, initialized with last 2300, and so we have a reference to the last node. Then with the 4, a new local variable I is allocated on the stack, initialized to a value of size -1, so 5, and we start iterating. X is x.previous, so this value will be overwritten by x.previous, this value 2200. So we refer now to the previous node. Size decremented, and we stop iterating. So the return value of x is assigned to the return value. We leave the methods, clear the stack frame, but hold on to this node we have found because we want to do something with it. What? Well, immediately return the item property of that node. The item property is 3030, so a reference to the integer wrapper object. And this is the return value, reference to the integer wrapper object. And so we hold on to this value because we're going to need it back in the invoker in the main method. But before continuing, what about the performance? So the get method we see here could be O1 because it doesn't do much, but it's the node method that makes it on. So get is on. Okay, let's leave the get methods and return back at the main. Now what do we need to do with this return value? Well, examining the return value of get tells us that we are dealing with the reference to an integer wrapper object. So on the right hand side of the assignment we have something that is of type reference to an integer. On the left hand side though, primitive type int. Now these two don't match. So normally we should even get a compiler error. But there's an implicit conversion taking place, which is called unboxing. For a detailed explanation, have a look at the corresponding ArrayList demo. The end result is that the local variable lm will get a value of 230. Printing the message yields element at position 4 is 230. How about replacing an element? Well, let's set the value of element at position 4 to value 291. First, local variable previous is allocated on the stack. And then set adds objects, not integer constants. So out of 291 using boxing, an integer wrapper object is first created. And then the actual set method of the linked list is called. Let's set up the stack frame. So we have the this pointer, the index value of 4, and a reference to this wrapper object, 3070. Now the return value of the set method represents the current value of the element at position 4 before it is replaced. In other words, the previous or old value, actually 3030. So the set method, after executing an index out of bounds check, but before executing the actual replace, first retrieves this previous value or old value by first invoking what I've explained earlier, so the node method. It returns the address of node at position 4, the node with fictional address 2200. And that is what X is referring to. After that, local variable old value is allocated on the stack, and it returns the value of x.item. x.item is 3030, so a reference to the integer wrapper objects. And then finally, the actual replacement of the value x.item. This value will be overwritten by element. Element on the stack is 3070. So this reference now will be replaced by a reference to this one. This happens now. And then the old value is returned. So we set the return value. And before leaving the method, what about big O? Well, set, like the get, is an on method. Looking at all these statements, apart from this invocation, these are all O1 statements. But it's the invocation of the node method as with the get that makes set a on method. Okay, that's it for set. We clear up the stack frame, we return to main, and the return value as set is a reference to this old value. Then again, what happens during the assignment, as with the get, this is of type reference to an integer, this is of type primitive type. You can't normally assign those two, so unboxing takes place. I'm going to skip the code and just show you the end results. So previous will get the value of 230. But the node at position 4 is referencing integer wrapper object 291. So that is correct. Okay, to resume, get is used to return an element, set is used to replace an element. Since both methods need to iterate through the chain of nodes before being able to perform the get or set operation with the requested node, both are on methods. Okay, that's it. Thank you for watching and for pressing the like button if you like this video. Bye bye.